Okay, this is Chapter 5 review problem, or it's actually the Benchmark 6 test, but it's Chapter 5 Benchmark 6 test. It's actually an old problem off the AP exam, 1999, number 5. The graph of the function f, consisting of 3 line segments, is given. So there's 1, 2, 3 line segments. This is a graph of f of x. In other words, the y-coordinate represents it's y equals f of x. G of x, on the other hand, is the integral from 1 to x, f of t dt. So g of x is not this graph. This is the graph of f of x. Okay? Now, if we did the derivative, g prime, we'd also have to do the derivative on the other side. The derivative would do what to that integral symbol? Cancel it out. Then you have to plug x in for t. So you have f of x. Since x is equal to t, we'd also do the derivative of x with respect to x, which would be times by 1. So what we actually find out is that is a graph of f of x. It's also a graph of g prime. So anytime we want to know what f equals or g prime equals, we can just look at the y-coordinates on this graph. That's kind of an important thing to notice first. All right? First part of the question, part A, compute g of 4. So that just means plug a 4 in here into the blue equation. So g of 4 equals the integral from 1 to 4 of f of t dt. So how are we going to look at this graph and get the integral? Area. Yep, the integral is found using the area between the curve and between the line segment and the x-axis. So from 1 to 4, let's split this up into pieces. So I'm going to draw some lines here. So I'm trying to get this area plus this area plus this area and then minus this area because it's below the x-axis. Count that as a negative integral. I realize area can't be negative, but the integral from 3 to 4 would be a negative value. In fact, what's going to happen with the integral from 2 to 3 and the integral from 3 to 4? They're going to cancel each other out, right? Okay, because they're going to be the same integral but opposite signs. This integral will be positive, this will be negative. So really what I need to focus on is the area between 1 and 2. So this first box is 1 wide and 1 high, so what's the area of this first box right in here? 1. Yeah. 1 times 1 is 1. This triangle, it's 1 wide and 1, 2, 3 high. So 1 times 3 divided by 2, what would you get here? 1.5. Good. So what's this answer going to be? 2.5, right? 1 plus 1.5 is 2.5. Okay, second part of part A, g of negative 2. So now we're going from the integral from 1 to negative 2. F of t dt. What do you notice that's different about the bounds now?
They're switched.
They're switched, aren't they? The smaller numbers on the top, let's switch those. Let's put the smaller number on the bottom. So let's put negative 2 on the bottom, 1 on the top. When you do switch your bounds, what do you have to put up front? Negative, right. F of t dt. So now we're going from negative 2 to 1. Let's just look at this big triangle right here. Look at this triangle right in here, this striped triangle. So it's got what would be the base of that triangle? What's the base? 3, yeah. 2 plus 1, there's a total of 3 across, up 4. So if you do 3 times 4 divided by 2, you get 6. This answer is 6. Whoops, negative 6 though, right? Because we got the negative on it. So the second part of part A is negative 6 because we switched the boundaries. Part B, find the instantaneous rate of change of g with respect to x at x equal 1. So when they say instantaneous rate of change of g, what are they really saying? The derivative, yeah. Instantaneous rate of change, that's expression for a derivative of g. So really trying to find g prime at x equal 1. How fast is g changing at x equal 1? Well, that would be the same as f of 1, right? G prime and f are equal. So g prime of 1 would be the same as f of 1. What is f of 1 equal? 4. This is 0.14. Part C, find the absolute minimum value of g on the closed interval -2 to 4. Justify your answer. Let's go ahead and make a number line chart for g prime. We're going from -2 to 4. And remember that g prime can be found by looking at f, which is also the y coordinate. So from -2 all the way to 3, what do we notice about the y coordinates? They're positive, right? So that means g prime is positive. At 3, the y coordinate is 0, so g prime is 0. Between 3 and 4, the y coordinate is negative. So the g prime is negative. So this tells me, if I'm going to make a sketch of g here, of the g graph, sketch of g of x, what's g going to start doing at -2? Increasing or decreasing? Positive first derivative tells me g is going to increase until it hits 3, and it's going to have a slope or rate of change of 0, and it's going to decrease again. How would I know how much it increased?
Area.
Right, the area between -2 and 3. This whole area here would tell me how much it increased. This little area underneath the x-axis would tell me how much it decreased. So maybe I don't have this drawn to scale. It's gonna increase much more than it's gonna decrease, because the integral from -2 to 3 is this area. That's going to give the amount of that area is much bigger than this little area down here. So you're going to have much more increase than decrease. So the question is, find the absolute minimum. Well, first of all, where does the minimum occur at? What number? -2. That's not your minimum, that's just where it occurs at. So what we really have to do to get the actual minimum is find g of -2. What would the y coordinate be, in other words, when you're at -2? Not really the y coordinate on this graph, but the y coordinate on the g graph. So I'm going to find, this is for part C still, g of -2. Do we already know that?
Yeah.
We do. -6, isn't it? So, okay. So -6 is the absolute minimum. And then to justify it, this number line chart could justify it, but you also should explain that because the area between the function and the x-axis is greater from -2 to 3 than the area from 3 to 4, that the graph is going to increase more than it's going to decrease, so the minimum will have to occur at -2. Any questions about that?
So we have to say that it occurs at -2, but it's.
I would show this and also talk about the fact that it increases more than it decreases on these intervals. Part D, the second derivative of g is not defined at x equal 2, x equal 1. How many of these values are x coordinates of points of inflection of the graph of g? Justify your answer. All right, second derivative. So you do the derivative of g prime, that gives you g double prime. Also do the derivative on the right, that would give you f prime. How can you see f prime on this graph?
Slope.
Right, that's the same as the slope or rate of change of f. So slope of f of x graph. Okay, so it looks like we've got positive slope, then negative slope. So let's make a number line chart for the second derivative here. So from -2 to 1, what's the second derivative going to be? Positive, right? Second derivative equals the slope of f of x. I think it's important to write this stuff out so you can keep track of everything. Positive slope, so positive second derivative from -2 to 1. At 1 we have a corner, so the second derivative is undefined. From 1 to 2 we have negative slope. At 2 we have a corner, undefined second derivative then. And from 2 to 4 we have negative slope. Question is, they tell you that there's undefined second derivative at x equal 1 and x equal 2. Which of those are points of inflection on g? Only at 1, because that's the only place what happens. That's the only place you see a switch in the sign, right? So x equal 1 is the only place where g has a point of inflection. because this is the only place G double prime switches signs. Any questions about that?